Hello everyone, today we're going to have the normal distribution. Normal distribution is a special type of continuous random variable. This still addresses the topic compute for the probability distribution of a random variable for both discrete and continuous data. So for these lessons, we're going to standardize normal random variable. Use the table for the cumulative distribution function of a standard normal distribution to calculate probabilities. A normal distribution. A random variable x with a probability density function f of x equal to 1 over square root of 2 pi times sigma e to the negative x minus mu squared all over 2 sigma squared, where x is from negative infinity to positive infinity, is a normal random variable with the parameters mu, where mu is from negative infinity to positive infinity, and the standard deviation sigma is greater than 0. Also, the expected value of x is mu, and the variance of x is sigma squared. And the notation n of mu sigma squared is used to denote the distribution. The properties of the normal distributions are the mode, which is the point on the horizontal axis where the curve is a maximum, occurs at x is equal to mu. The curve is symmetric about the vertical axis through the mean. The curve has its points of inflection at x is equal to mu plus sigma and mu minus sigma, and it is concave downward if x is mu minus sigma to mu plus sigma, and it is concave upward otherwise. The normal curve approaches the horizontal axis asymptotically as we proceed in either direction away from the mean, and the total area under the curve and above the horizontal axis is equal to 1, and the distribution is mesokurtic. For any normal random variable, the distribution of plus or minus 1 standard deviation is 68.27%, plus or minus 2 standard deviation is 95.45%, and plus or minus 3 standard deviation is 99.73%. To standardize a normal random variable, if we want the mean to be central or to be centered at 0, and the variance to be equal to 1, we standardize the normal random variable, and it is denoted by z. The cumulative distribution of a standard normal random variable is denoted by phi of z equal to the probability of z less than or equal to z. For example, we want to get the standard normal area to the left of a certain value, p of z. What we want to do is to solve for, or to look at it at the normal random variable table, or to the z table. So for example, we want to get phi of 1.50. So what we want to do is to check for 1.5. So we divide it into two parts, the 1.5 and the 0. At the left side, you check for 1.5, and at the top, you look for 0. So 1.500. So if you want 1.52, you use this one. So for 1.50, the normal area to the left of 1.50 is 0.93319. So at the left side, you look for 1.5, and at the top, you look for 0.00. Let us use a normal distribution Excel file that I have provided, but you can still use checking your statistical table for this one. So the mean for a standard normal random variable is 0, while the standard deviation is 1. All the green parts are fillable. For the first one, z is less than 1.32. So 1.32. So less than is to the left. So this one is to the left, this is to the left, this is greater than to the right, and this is in between two values. So for less than 1.32, we have 0.9066. Less than 3, so this is less than 3. So 0.9987. And then greater than 1.45, so greater than is here. So 1.45. And then greater than negative 2.15. While in between, we also have in between negative 2.34 and 1.76. So there it is. Find the value of z such that the following probabilities hold. So again, since this is standard normal distribution, so the mean is 0, the standard deviation is 1. So if we're looking for the probability less than, so that's to the left, and the probability is 0.9, the value of x is 1.28. To the left of z is 0.5, so if the area is 0.5, x is 0. For greater than z is 0.1, so that is 0.1, so greater than this to the right, so it is again 1.28. If it is 0.9, so greater than 0.9 is negative 1.28, and for this one it would be in between two values. Since this is symmetric, so since this is from negative 1.24 to positive z is 0.8. So what we're going to do is, if we have greater than z, it is negative 1, greater than z, so this is negative 1.24, so 0.1075. So meaning we're looking for 0. So 1075 plus 0.8, so 9075. So that's 1.32552. So since the area to the left is 9075 minus 0.1075 for negative 1.24, so the difference is 0.8, so that's why we have 1.32552. So you can write your solutions here. Okay. Determine the value of z to solve for the symmetric area of 95%, 99%, 68%, and 99.73%. So for this one, we're still going to use the Excel file, and take note that we're using symmetric areas. If we are going to have 95% of area in between, so if we have 95% area here, so the area outside would be 5%, meaning 2.5% to the left and 2.5% to the right. So that means 0.025 on the left side. So it would be negative 1.96. Assuming symmetry, so that would be negative 1.96 and positive 1.96. But to simplify that, we can have this one, 0.95. So that's negative 1.95996, or simply negative 1.96 to positive 1.96. For 0.99, it would be negative 2.576 to positive 2.576. For 68%, it would be from negative 0.99 to positive 0.99. And for 0.9973, it would be from negative 2.99998 to positive 2.99997. So this is somewhat the same as what we have mentioned in the empirical formula. So if we have plus or minus 1 standard deviation, plus or minus 2 standard deviation, and plus or minus 3 standard deviation. Here are some of the references used to make this video, so you may use this to study ahead of your lessons.